Hello, this is Professor Espinosa, again continuing with the lecture on data requirements. This is DR3.2 data modeling. We reviewed the relational model in the prior lecture, so now we're going to get into the nuts and bolts of data modeling over this and the next couple of slides, couple of lectures. So let's begin with data modeling. And so let's take this example here. In this example, you have a purchase order. And if you look at the purchase order, this is something that you would probably get in a piece of paper or on the screen. And you want to purchase a number of different computer items. Computer box, computer display, some keyboards, some mice, and so on. So you place one order, and that order is order 99001. That needs to be recorded in the database. You have an order date. You have an order description. You have the ID of the client who placed the order. Okay. Now you also have some data about that client, the address, the shipping address, and so on. And then you have data about the various line items that make up that order. So in this case, we have 4 line items in one order. So we have in the first line item, we're ordering 10 computer boxes, and the unit price is almost $2,000. Okay, and then we have 10 computer displays, 12 keyboards, and 12 mice. And the order total is $25,396.60. So the question is, how do we record all this data in a relational database? We were talking in the prior slide that a relational database is tables. Each table has a unique name, and each table has columns that have unique names, unique column names within the table, and that every row in those tables is addressable. So how do we design a database that will hold all this information and help us manage information like this for purchase orders? So in the next page is the answer. So in this page, in the prior page, this is what the user will see. This is what you would display on the screen or what you would print in an invoice. Okay, but this is how the data is stored internally. So if you look at these tables here, we have 5 tables. In one table, we have clients. So we have a record for every client. In the next table, we have orders. So we have one record for every order. And we have a table called products, so we have one record for every product that the company sells. In addition to that, we have this other table called line items. Why? Because an order may have multiple line items. So if you look at in the line items table, if you look at order number 99001, you will notice that there are four different records, one for each of the line items. And what we have is a product ID specifying the product that that line item contains, and how many units of that item have been ordered. We also have this table called client com. A client com is a table that I have here for illustration purposes. It's a client that has it's a table that has a record for every time a client contacts the company. So you have a client and a client ID and a date. And then you put the comments, whether that was a telephone call or an email or whatever you want to record something about your interaction with that client, you can store it in that place. So once again, let's go back in here. And I'm going to be toggling back and forth with this PDF that has the table, so you can see there. Okay. And the actual purchase order display that I have on the screen here. So my question to you is, if you were designing this from scratch, the question is, how many of the tables that I just showed you would need to query to get that the information that I'm pointing at on the screen. So, and the idea is that you need to use the minimum number of tables required to produce this display. So in other words, this is how you store the data internally, but then through queries and through your application, through the software, you provide a display that looks like this. So which table would you need to query to retrieve the order number in the purchase order? So that's my first question. So you think about it for a little while. You have to find the minimum number of tables that you would need to provide this information. Obviously, there's a table called orders, and you can get the order number from the orders table. So that's one table. So far, we're only querying one table. I can get the order number from the orders table. Notice that I can also get the order number from the line items table, but that will be two tables. And line items has 4 records for the same order. So I'm just going to stick with the orders table. All I need is the orders table to retrieve the order number. So let me go back here. How many tables do I need now if I want to also retrieve the order date? Well, if I need the order date, I go back to the table, and I can see that the order date is also contained in the orders table. So far, I only need the orders table to retrieve the order number and the order date. Now, I want to get the order description. So I go back to the table, and I can see that the order description is also recorded in the orders table. So I'm still relying on a single table, which is the orders table. Then I have client ID. So I go back here, and I can see that the client ID is in the orders table. That client ID is the ID of the client who placed the order. But notice that I also have a client's table, and it also has a client ID. So I could have used that table too. But again, the rule is let's use the minimum number of tables needed to get the query. Okay? So I'm going to stick with the orders table. So far, that's the only table I need. I have the order number, the client ID, the order date, and the order description. So now, let's say that I want to get all this client information, the shipping, the client full name, the shipping address, and so on. So now I go back, and I can see that I no longer have the information I need in the orders table. That means that I need to go to the clients table to get the client name and the client address. So now I need 2 tables. I need the orders table and the clients table to reproduce the purchase order. So if I go back here now, if I go to the to the line items, well, again, I need to get the line item, product ID, product name, quantity, unit price, and so on. So the line item is no longer either in clients or in orders. I have to go to the line items table. So in the line items table, for order 99001, I have 4 items, line item 1, 2, 3, and 4. So in order to retrieve the line item to display in the purchase order, now I need to also query the line items table. And if I go back here, you'll see that the product ID is also contained in the line items table. So far I need 3 tables, clients, orders, and line items. Okay. If I want to put the product name in addition to the product ID, okay, well, the product name is not in the line items table anymore. I have to go to the products table. So now I need a 4th table to get the information. So I have to go to the products table and look up the product ID and figure out what the product name is or the product description or whatever else I need. Same thing with the price. If you look at here, the unit price is also in the products table. So I need 4 tables to retrieve all this information. Now the total price is what we call a calculated field. The total price is quantity multiplied by unit price. So I don't need to query a specific table to get that information. I just multiply those 2 columns. So to recap, in order to reproduce this purchase order, I need to query 4 of these tables. I need to query the clients, orders, products, and line items. Okay? So the difference I'm trying to describe here is that this is what the user sees and you want to make it nice and neat and provide the good information layout on the screen, a good visual interface, okay? But this is not necessarily the best way to store the data internally. The best way to store the data internally is like right here. Now, think for a moment, if you wanted to apply the relational database principles that we talked about in the prior lecture, I want to see if you can find out which will be unique identifiers of the rows for each table. For example, if I want to identify a specific order, if I want to find data on a specific order, naturally I'm going to go to the orders table. So in the orders table, what would be the specific field or column that will uniquely identify a row in that table? So the answer is order number. Once I know an order number, I can identify the row I'm looking for, and I can get all the information I need for that order. For example, if I'm looking for order number 99003, I can go to that order number and then go to the right and find the client ID, the order date, the order description corresponding to that order. Okay. Now, if I'm looking for clients, naturally I look at the client ID. Once I know the client ID, I can retrieve all the information I want about that client. For example, client ID Glee is Guangzhou Li, Professor Li. And I can get his address, I can get his city, state, and so on. All right. Same thing with products. If I want to find a product, I look at the product ID. So once again, client ID is the column or field that uniquely identifies a client in the client's table. Order number is the field that uniquely identifies an order in the orders table. And product ID is the field that uniquely identifies a product in the products table. All right, so far this looks pretty simple. But now let's complicate things a little bit. How about line items? In line items, I can no longer use a single column because the order number, as you can see, gets duplicated. So order number 99001 has 4 rows. Order number 990002 has 2 lines. And the line items, if I only look at the line items, line item 1 gets repeated for each order. So I have a line item 1 for order 990001, and I also have a line item 1 for 990002. So in order to uniquely identify a row in this table, I need to have both the order number and the line item. So if somebody calls me and say, hey, look, I placed an order and the keyboards haven't arrived, I'll have to ask, well, give me the order number and the line item that you're talking about. And the person will come back and say, okay, it's order number 990001, line item 3. And then I can find the exact record that the client is referring to. So the key field that uniquely identifies a record in line items is actually what we call a dual key. It contains order number and line item. Same thing with client com. In the client com table, in order to identify a particular communication with a client, I will need to have a client ID and a client date. Once I have a client ID and a client date, I can find that because, for example, client ID Alberto has 2 entries, which are for 2 different dates. Okay? So now, that illustrates the concept of what we're going to call entity integrity. So in relational database, we need to have that unique identifier for each row in each one of the tables. And we're going to call that the primary key. We're going to talk about that a bit later. Okay? So in the clients table, the primary key is client ID. In the orders table, the primary key is order number. In the products table, the primary key is product ID. In the line items, it's a dual column situation where we need order number and line item as the primary key identifier. And in the client com table, we need client ID and date to uniquely identify a row in in the table. Now, all these tables need to be linked together. And in order to link these tables together, to form a database, in a database, all the tables need to be logically related to each other. So in order to link the tables, I need to find a common field that links the tables. For example, how do I link orders and clients? Well, it's through the client ID. Client ID is common. It's a common field in both tables. In the clients table, the client ID is the client record. So if we want to find a client information, we go to the clients table and we find that client. In the orders table, the client ID is the ID of the client who placed the order. So now, in order to place an order, you have to have a client ID. And that client ID has to be valid. Where do we validate the client ID? We validate the client ID in the clients table. So for example, client ID Carmel comes and wants to place an order, 990002. Well, before we can allow Carmel to place an order, we need to go to the clients table and look up Carmel to see if Carmel is a valid client. That's what we call referential integrity, which means that the data in one table has to be consistent with the data in another table. In this case, the client ID in the orders table has to exist in the clients table. Otherwise, we would not have a client name, a client address, a client city. We would not have any data on clients. We would not be able to deliver the products. We would not be able to bill or anything like that. Similarly, we have, let me see, in the client communications, in client com, we have another client ID. So once again, that client ID in the client com has to be a valid client. Where are we going to look up to see if the client is valid? We're going to look it up in the clients table, of course. That's where the clients, the official records for the clients are. So client ID will be what we call a foreign key because it has to be validated against the clients table. How about products? Okay, so products is a table by itself. We don't need to validate it against anything. But in line items, we have an order number and a product ID. Those two need to be validated. So line items, the order number has to be an order in the orders table. Otherwise, I don't have any order data. You know, I need to have order data. I need to know the client ID who placed the order date, the order description, all of that. But when I enter the line items, I need to associate those line items with a particular order that those line items belong to. So if I look at the first column order number, that order number, 990001, needs to be validated in the orders table. In other words, when I enter a record in the line items, it has to be associated with a valid order number. Same thing when I put the product ID. The product ID must exist in the products table. So I need to go into the products table and ensure that those product ID, that particular product ID for the row exists in the products table. That's the validation we need to do. All right, so if you follow all those principles, what I'm going to be lecturing next about primary keys and foreign keys will make sense. And I'm trying to give you the intuition here that for a table to have good data integrity, you have to have primary keys or the unique identifier of every record in each table, and foreign keys, which are the keys that link tables so you can relate them. Okay, so you can do the same thing here. This is the schema representation of the tables. So again, if you have too much data on the tables, you can go to the schema and list all your fields and your tables in here. So we have the clients table, okay, and the primary key for the clients table will be client ID. We have the orders table, and the primary key for orders will be order number. We have the products table, and the primary key for products will be product ID, because product ID uniquely identifies a product in that table. For line items, we have order number and line item is a dual key. we need two fields to uniquely identify a row in line items. For client com, same thing, we need a client ID and a date. So each communication entry has to relate to a client on a given date. And I've added a new table called product types. So in product types, just to illustrate how you grow a database, and we're going to talk about this later, let's say that we want to offer more than one product type. So what we do is we create a new table called product types so we can list all the official product types that the company carries. But then we need to add a field in a products table called product type, which is the second field you see on the screen. That product type has to match one of the product types in the product type table. And that's how we expand the databases. Okay, so in the next lecture, we're going to be talking about design goals, and we're going to be talking about primary keys and foreign keys. We're going to be talking about data integrity, which are two types of data integrity, entity integrity and referential integrity. I will explain this in detail in the next section, so I'll see you in a few minutes. See you shortly. Bye.